Continuing on our differentials of natural logarithmic functions, we're going to look at examples with things we have learned earlier on, specifically finding the equation of tangent lines, implicit differentiation, and stuff like that. Okay, so let's start with it. So we would like to find an equation of the tangent line to the graph of the function given below, y equals 3x squared minus natural log of x at the point 1 and 3. So if we remember the equation of a tangent line as y minus y1 equals f prime of x evaluated at the point x1, y1 times x minus x1. So basically, we just have to find the y prime and evaluate it at x1, y1. Okay, so let's go ahead and do it on this side. So f prime of x, or y prime, is 6x minus 1 over x. Now, to evaluate this function, f prime of x, at the point 1 and 3, what's going to be? 6 times 1 minus 1 over 1, which is 6 minus 1 or 5. So now we just plug in the values here in this equation. Y minus 3 equals 5 times x minus 1, which is 5x minus 5. And the final answer, y is 5x minus 2. I hope you guys remember implicit differentiation. Now, in implicit differentiation, guys, we do not have a nice little y in terms of the other. So what we normally do is we apply it to the whole equation and then proceed from there. So here, in implicit differentiation, we would say differentiate with respect to x. Basically this, that means we're doing differential of natural log of xy plus 5x equals differential of 30. Now differential of 30 is easy, it's 0. Here we're going to have a differential of natural log of xy plus differential of 5x. So differential of 5x is simply a 5. Now it's the natural log of differential of xy. That's the one we have to look at. Okay, now notice the first thing is natural log is the first one you have to work. It's like a chain rule, remember. So it's going to be 1 over xy differential of xy plus 5 equals 0. Now the differential of xy, it's a product of two functions. So it's going to be what? 1 over xy. This is the first function, second function. So differential of the first times the second function plus x times the differential of the second function plus 5 equals 0. Okay, so 1 over xy times differential of x prime is 1, y, plus now x times differential of y. Now notice this one and this are different. So simply just write dy by dx because the differential of y with respect to 1 is what? Y to the power 1 is simply a 1. So it's dy by dx plus 5 equals 0. Okay, now you just gather, take the 5 on the other side, xy is on the other, and get dy by dx on its own. So basically now what, if you remember, is we have to solve for dy by dx. So it's going to be y plus x times dy by dx equals 5. And this was in the front was 1 over xy, and it's a minus, guys, here. Then you multiply by xy, you get what? Y plus x times dy by dx equals minus 5xy. Then subtract y and divide, so x times dy by dx equals minus 5xy minus y, and dy by dx, the final answer is minus 5xy minus y over x. You can just leave it like that. Okay. Now guys, we're going to solve something called logarithmic differentiation. Now, here logarithmic differentiation means that if you have this expression, if you can find dy by dx, you can do the normal differential, it's not a problem. But when you do logarithmic, what it simply means is you're making your life simple because you're going to apply the log properties. And then you do normal differentiation. So I'm going to show you the steps. So in logarithmic differential, it means taking the log on both the sides. And we prefer to take the natural logs. So what do we get? Natural log of y is natural log of x square root of x squared plus 1. The reason is we want to use the natural log properties to make life simple. So this is natural log of x plus natural log of square root of x squared plus 1, which is natural log of x plus, remember this one is the same as saying natural log of x squared plus 1 half. So half times natural log of x squared plus 1. And now we are going to differentiate this whole equation. Differentiate with respect to x. In other words, d dx of natural log of y, differential of natural log of x plus half times natural log of x squared plus 1. It's 1 over y times, it's like, to remember differential of x and y difference is simply it's dy by dx equals, this is 1 over x plus half times, it's a constant, 1 over x squared plus 1 times differential of x squared plus 1. So what do we get, guys, here? We'll write this again. 1 over y times dy by dx equals 1 over x plus half times x squared plus 1 differential over x squared plus 1. So what you're getting is 1 over x plus half 2x on the top, x squared plus 1. Clearly the 2's cancel out. Here we have 1 over y dy by dx. 1 over y dy by dx equals 1 over x plus x over x squared plus 1. Remember, you're solving for dy by dx. That means you could remove the y's here. So dy by dx is y 1 over x plus x over x squared plus 1. And then you can do the y. Remember, the original y was what? X times square root of x squared plus 1. 1 over x plus x over x squared plus 1. It's just that when you do the logarithmic differentiations, guys, it makes life simple for you because you can use the log properties. That's what basically we are doing here. Okay? Okay, now we're going to apply, solve differential equations, remember? And in this one, if you recall back in chapter 4, we, earlier on, I think chapter 1 was it? Yeah. So here we were talking of a differential equation as an equation that involves derivatives or differentials. That means we'll have an equation with differentials involved in it. And this time we're going to add natural logs like y prime plus y double prime equals natural log of x. So when we want to solve a differential equation, it's like we can define an explicit expression of y in terms of x. In other words, what y will satisfy this equation. Okay, so let's look at an example here. We would like to show that y equals x natural log of x minus 4x is the solution to this differential equation. What basically it means is take this equation, plug it in. So x is fine, y is fine. We have to do y prime before we plug all the terms here. So let's find y prime. Y prime is what? X natural log of x differential minus 4. Okay. Now this is a product rule, guys. Keep always in mind when you have a product of two functions, it means product rule of differentials. So it's x prime times natural log of x plus x times differential of natural log of x minus 4. What do you get? X prime of this is what? Natural log of x plus x over x minus 4, which is natural log of x plus 1 minus 4, or natural log of x minus 3. So once we have got y prime, guys, We just have to plug it in this equation and prove that the left-hand side equals the right-hand side. So you only have an x. Y is what? X natural log of x minus 4x minus x times y prime. This is my y prime, which is natural log of x minus 3. Okay, let's solve this one. X minus 4x is what? Minus 3x plus x natural log x minus x natural log x plus 3x. Clearly everything cancels out, so it's equal to 0, which is equal to the right-hand side. So when you have to show that this is a solution, basically you plug in the right-hand side values and prove that it is equal to the right-hand side values. Okay, so guys, practice problems. Okay, so we would like to find an equation of the tangent line, implicit differentials, solution of differential equations, and logarithmic differentiation. Guys, keep that in mind. These are very same problems we have done in the practice ones here, in the examples. In this session, use that as a base to do these problems. Thank you.